All right. Good afternoon. Everybody can hear me okay? All right. So very excited to have you all here, and I really want to thank you for taking your time to come and spend your day with us. We've had a really exciting, a couple of years of watching our customers build some pretty, interesting and innovative things on our platform. So what I want to take take 40 minutes with you today is I want to peel back the covers a little bit and share with you how companies like Netflix, who we hear about a lot, and Pinterest, and Astro out of Malaysia, DBS here, Grab, like some really smart, innovative companies, how they think about decision making using analytics. And more importantly, as we kind of go a little bit deeper, how do they use technology to make that possible? So I'm going to do a little bit of a deeper dive into what these platforms look like, what the platforms look like, and why these customers build the way that they build. So the first thing we'll do is let's go on a journey. And what I'll share with you is what a kind of a normal process looks like in how decisions are made and the roles, the people who are involved in this. So I'd like to introduce to you EarEcstasy. Now, okay, I'll be honest with you. EarEcstasy, they're not a real company, right? But what they are is, I've been working in this industry for a while and have been with AWS for a few years. This is an actual representation of how our customers tend to progress. So the kind of first workloads that they work on, and then moving into the second, the third, and ultimately how they move into a much more agile operations. Now in 2005, EarEcstasy was kind of a traditional manufacturer. They created high fidelity headsets and they did what you think they would do. They put nice sound into your ears. They had a big problem though. They were a traditional manufacturer. They produce headsets, they release them to distributors. Distributors go to retail and then they lose visibility of the customers. So they're building what they thought the market wanted and they measured the signals if customer liked it based on if increase in sales were happening or not. Now, fast forward a little bit. In 2018, EarEcstasy has released smart buds. And smart buds do some pretty cool things. They're instrumented headsets. Now, what do they measure? They measure heart rate. You can get some interesting information for heart rate, and they have GPS tracking. They even have the cool little Alexa voice service, so you can hit a button and give it some commands. They also have integrated this idea of what can we do if we had a linked mobile app and the headset links to our mobile, and maybe we could take pictures and get some context over what the person is looking at when they're listening to music. I don't know, let's build something like this, let's take it to market. But the important thing isn't just that they released a new fancy headset. They have for the first time the ability to have a direct communication with their customers. Now this may sound familiar to some of you and it may be very similar to what you're trying to do, which is how do you have a better communication with customers, listen to signals, and give some sort of personalized experience? So they started first with who are the people in EarEcstasy who needed to make this experience possible. And they started with the first two people who we often see are the ones who lead these journeys. The person who's looking after the finances of the company. So we have in this case Lim, and she's the head of finance. And the second is the person who's building the product, trying to find out, is this the right thing to take to market and will it be successful? They have some specific questions. So Lim will be looking for things like in her mind, she's thinking about, is there an impact on cost of production based on the quality of what we're producing, right? So another might be, we import a lot of parts to make these new smart buds. What's the, what are we looking at as far as supplier performance? And a third thing might be, they need to manage inventory holding costs. So they are holding inventory of supplied goods. And then also when they manufacture goods, they may hold it for a period of time before they ship. So very traditional sort of ways to look at the business through the lens of finance. Now let's shift over to Raymond. And Raymond, being head of product, is very interested in where are these going to sell? So what regions as we move these to customers, looking for that kind of signal, understanding better based on what has been sold, what should the demand forecast be? And do we have an idea across product category what that demand forecast might look like? The third is for the first time, they might look at things like social sentiment. Well, that's pretty interesting because that doesn't live in the transactional system. So now looking for external signals to understand, do customers like this product and are they responding well? So let's look at Lim and let's look at Raymond as finance and head of product. Now, to answer these questions, they can't really go back to the traditional systems they had because they have two on-premise systems. One is they have a CRM system, so they have something that captures all of the transactional details going downstream. and they have manufacturing information, and they also have their ERP, which is an ERP, and then they have financials. Now, to extract all of this and apply analytics onto it was just hard. They're having a hard time answering these questions. So they moved to a different kind of architecture. And this is a very common pattern that we'll see, which is there may be a very traditional sort of view that a company has moved towards because at that time, it seemed like the right way to go. But there's a couple limitations where they say, maybe as Raymond is launching this product and he wants to get some quick answers, he doesn't necessarily want to drop $1.5 million or $2 million into building some massive system up front. Just needs to pull a little bit of data, ask some questions, and see if it's the right approach. The second is it's a capacity issue. And the traditional IT process has been, we need to plan forward at least 2 years. So it's typically 2, 3, sometimes even 5-year provisioning process and buying capacity. And if any of you have done this before, you know it's pretty notoriously hard to know what your business is going to look like and the size of data and how many people use this. All that stuff you need to know to look forward 2 or 3 years can be hard. So often businesses will take a risk-sensitive approach and they'll over-provision. And the third is, if I want to ask a question, I may not want to wait 9 months before I can get the hardware in, get operations to look at it, and start to build. So these are very traditional on-premise challenges. So they moved not just to cloud, because it's not magic to move to cloud. They moved to building data pipelines on cloud. Now, if this doesn't sound familiar, or if you haven't worked in the data pipelining space, I'm going to dig a little bit deeper later onto why a data pipeline is fundamentally different than a traditional approach, and how it helps EarEcstasy and helps those big customers that I just named, how it helps them move a lot more quickly. There's a very common pattern, and sometimes when we talk in the big data space, we talk analytics and AI, people kind of jump to a future state, but there's some steps to get there first. And these are kind of the learning steps or the building blocks. The first tends to be a project that is around modernization and consolidation. Now, let's go back to Lim, and Lim had those questions, right? She had questions around quality issues, supplier performance, and inventory holding costs. She knows, because Lim's been working in this business, she generally knows where the data lives, or where she believes that it lives. She looks back first to the CRM system to pull things like order history and returns. She then looks to the ERP system to understand inventory and production data. So she knows where the systems live. Now, to pull those together has been hard before because they didn't really have a nice system that integrated this. So there's a process, and this is something that the more that you talk to AWS customers, there's a process that they tend to go through, which is called a working backwards process. So rather than starting and saying they're going to pull all the transactional data or all the ERP data and then do something with it, our customers tend to start with one problem they're trying to solve, or 2 problems they're trying to solve, and they pull the smallest amount of source data. And this is a really different approach. So the smallest amount of source data, and they put it through a data pipeline. So there's an ingestion process, so the data is collected, it's put into storage, some iterations are done to test that data, have hypothesis, and then you see, am I right or wrong? Once you get some answers, and then that can be pushed out to the user, so through a visualization or consumption process. Now, so that's on the left side, we have all the data sources. On the right side, we're going to start to fill in the users or the personas that attach to this system. Here's a core principle. As you're building, it isn't just about data pipelines, it's about starting as small as possible. So whether it's EarEcstasy or other customers, tend not to take big bang approaches because big bang holds a lot of risk. It's 12 months to get started and a lot of money that's been sunk in capital costs. So this idea of, is it possible to start really small, find out what's working, and then iterate on it? So let's go back and let's look at this architecture. On the data source side, we have let's say a financial system, and in this case, they're using Oracle Financials, and that's fine, and it does what they need it to do. And on the ERP side, they're using SAP R3, which is a common production system around inventory management and production management. So that's fine, they have those. Now, Lim doesn't want to re-architect everything they have. She thinks that there's a small amount of data in each of these that if she could just extract it, she could ask those first questions. So she asked for the smallest amount of data, and instead of trying to re-architect everything, like you would have heard earlier today, we have database management or database transfer services, and we have migration services. They just want to start really small. So they're going to use the native extract tools that they have already. So they'll use the Oracle data pump. So they'll just use that and say, okay, we'll move that up into the data landing area. And for SAP, we have a technology partner called Bright, and Bright happens to be really good at pulling data out of R3 and landing into S3. So LIM has said, ask for the very shortest path to get enough data into the data landing area. Now, the data landing area is just the first step. It then needs to flow into the data lake. Now, we're going to deep dive in, I think, 2 presentations from now. We'll deep dive into what a data lake really looks like and how you might build one. But let's just say for now, it moves into the data lake. Now, the data lake is just a place where a lot of data will get pulled together. It has some context, and people can then use it. LIM has 2 different types of data and 2 different kinds of questions that she wants to ask. She's a Tableau user, and Tableau, being another technology partner of ours, it's a good product, and it's good at asking questions around not just structured data and unstructured data, dimensional and non-dimensional. So when she's asking questions around dimensional data, and where we're thinking about things like performance over time, or performance by category, or doing some analysis of suppliers, data warehouses tend to be very good at answering those kind of questions. Just nice structured data. So they need to have a data warehouse, and so they opted to go with Amazon Redshift, which is a fully managed data warehouse. I'll talk a little bit about Redshift in a few minutes. But then also, she's got some data that's being pulled out of the manufacturing systems that isn't necessarily nice and dimensionally structured. It doesn't fit into a warehouse. It's living in the data lake, and she wants to ask some questions around it. She wants to look at the impact of quality issues on cost of production. So she needs a direct query service. So she uses a service called Amazon Athena, which is the ability to go ask questions that you don't really know what you're going to ask to begin with. So it's a schema on read sort of service. Well, these 2, they have these, and she can just read directly from the data lake, build into both of those services that are fully managed, and then use Tableau to consume from them. So that's okay. She can ask her questions to begin. Now, the reason they went with Amazon Redshift, and if you haven't used this before, it's worth calling out a few details. So Amazon Redshift is our fully managed data warehouse. One of the things that will make it attractive to some of our customers is it costs about 1/10 of what a normal data warehouse would cost. But more important, it starts really small, so you can have gigabytes all the way up to exabytes. So because it was built on the cloud and it was built to be native to AWS, it scales. It also is able to pull data out of Redshift, but we also have reach through where you can issue a query to your data warehouse that reads out of your data lake. And that's pretty interesting if you're not looking to load everything up into a hot cluster. So there's a few benefits to it. So at scale, it operates pretty quick, and so it was designed to scale from the beginning. We do support a number of open file formats. So if you have data that's living in your data lake, you don't necessarily need to convert it to be able to use it within your warehouse. Security is something that we built in from the beginning because it is cloud native. It uses our auditing and our management governance services on top. And like I mentioned, it tends to operate at about 1/10 of the cost of a traditional warehouse. So they opted to go with Redshift for their data warehouse. Now let's step back a little bit. To feed the data warehouse, where did it come from? It came from the data lake. So what makes a good data lake? Now, all of you're smart people, and you've been sort of shopping around to, is a data lake a good thing? Is it right for us? What does it need to have? So I'll just give you the view, not on the technology, but what we think is really a good pattern. So if you're going to build a data lake, some things to make sure that you're getting right. And this is kind of the best practices we're seeing. One is that today, you know that you have transactional data. Everybody here has it. You may also have some unstructured data in your business. That could be things like emails, or it could be other sorts of log files that you're capturing off your digital assets. But you don't necessarily know in 12 months what else you're going to collect. Are you going to start collecting video or audio or other geospatial data? It's hard to know. So making sure the data lake could support what you have today in any file format, and it's also future-proof. Needs to also make sure that whether you are a Tableau user or you are any sort of data scientist with any tool that you've got, or you're loading into other databases, that there's a flexibility as far as endpoints. So having a good API interface so that your data lake is available to everybody who wants to use it. So let's talk about how Raymond takes advantage of the data lake. Now, he starts with a very specific question, which is, what are the regions that, that the earbuds are selling? The second around demand forecasting, and third around social sentiment. So he first looks into the data lake and says, does it have what I need? So some of that data is there. So the CRM data has been loaded into the data lake from Lim's work, but it's not enough because he also needs to pull data out of social. So he needs to pull data that is trending data, maybe mentions about the product, or just seeing if people are happy with it. Now, we talked about start small and iterate. Now, as we're pulling together data that is unfamiliar, right? So pulling in data that maybe Raymond is looking at for the first time, there's a very important process that tends to be that sort of first introduction into how to use a data lake in a unique way. And it's around experimentation, validation, and then scale. So starting with hypothesis, testing those, and then once those sort of have some weight, then building those out. So he goes back and he looks into the data lake. Says the CRM data is in the data lake, that's fine, but I now need to pull some more data in. So maybe he pulls additional data out of CRM, that goes into the data landing area, but he also starts pulling data out of social feeds, Twitter or whatever. And in order to pull that, that comes in through a different process. You don't just land a big batch, right? You start to pull this data, you pull the data. That goes through an event streaming service called Amazon Kinesis Streams, and it lands into an event staging area. Now, we've kind of split the top and the bottom here, and we'll talk a little bit more around this, but the top area are data pipelines, and the bottom layer are event pipelines. So again, as we start to think about this decoupling and building the right feature functionality on the layers, we have data on the top and events on the bottom. Now, events over time are collected up into the data layer for analyzing and then also building predictions. So we start to move the events data up into the data landing area. All of that flows into the data lake, and now Raymond is able to use the tools that make sense for him. So he's not a data analyst. He's not using programming tools. He just wants a BI tool. In this case, they decided to go with Amazon QuickSight. But really, it could be any BI tool that reads off of your data warehouse. Now, that gives him his dashboard. It lets him look at things like product performance. It gives him sales trends. It gives him that sort of view that he needs around product performance. But he also wants to look at what's trending. Like, do people love or do they hate smart buds? Was there a weird product update patch that we put out and people love it or they don't love it? There's features, functionality. He can now listen, using Elasticsearch, flowing into Kibana to give him some sort of real-time view or near real-time view on trending that's happening on social. So again, being able to pull from the data lake to answer very different questions. Now let's dig into what a data pipeline looks like. We talked about it a couple times. The first core premise of a data pipeline is we think about decoupling. Now decoupling is, and again, if you're an AWS user, you probably have already realized and you've experienced what a difference this makes. Not having all of your compute and storage tied together, not having big appliances, not having things that become very static or hard to then add capacity to. A data pipeline gives you fault tolerance and the ability to scale just the storage if you need more, or just the ETL capacity if you need more. So a normal process for a data pipeline is data will land into that landing zone, or what we'll call raw data. It uses a service called Amazon Simple Storage Service, or Amazon S3. Amazon S3 is object store. I'll go on a little bit into the storage capabilities in just a moment, but essentially it lands in a raw data area. It then flows using something called Amazon Lambda, and Lambda says anytime new data comes in, I want to trigger an action. So as opposed to having the data flow directly into the ETL tool, every time there's an update to the data in raw data area, it triggers it and says, hey, please go run in this server or in this service, run a little bit of ETL and prepare the data. So in this case, they prefer to use Amazon EMR, which is Hadoop, a fully managed Hadoop offering, and using Spark. Now there's a couple tools, and the nice thing about a pipeline is if you want to use Hadoop, you can. If you want, you could just swap that out for your ETL tool of choice. Now, we heard earlier that Glue launched here in Singapore just this week. And Glue has been out for a little bit, and now that we have it here, this is something that EarEcstasy is using for doing the ETL and catalog management. So as there are those transformations and the data needs to flow, be tagged, and then be marked up into the data lake, which is, again, being implemented using S3. Glue helps to put the context. What happened during ETL? Is this product data? Does it contain PII? What was the source of that? When was it last refreshed? All the things that you need to know to be able to make that data lake have meaning. And then finally, the data lake can feed, we've already seen, can feed things like Elasticsearch, it can feed Athena, it can feed Redshift. So a common data pipeline tends to look like this. The landing zone is a set of S3 objects and containers. Then it flows through some ETL process. It flows then into the data lake, and that's managed with an underlying Glue or some sort of catalog management service. And then it is then consumed from the data lake up into the higher level services. Now, we talk about S3 because S3 is kind of the underpinning for all of our storage. But there you do have a couple of options. So if we look down into what storage building blocks tend to look like, the most common that we have is object storage. And you see that on the bottom. So object storage is S3. Sitting right next to that, we have archival storage. And that's Glacier. And Glacier is, if you kind of think of it as like a virtual tape drive, it's take what's sitting in S3 and then take that and move it into cold storage. And you pay about a fourth of the price roughly to keep it there. But we also have things like block storage, which may be very useful if you're running something like a database and you have a very specific file type that you need to store on disk. Or if you have EFS for file system storage. So there's a lot of different types that you have, so you're not just rammed into one if that doesn't make sense for you. Data can flow into storage through a few different mechanisms. We have storage gateways, we have streaming data that might come through Kinesis Firehose, file data that can be synced. We've been in the cloud business for about 12 years now, so we launched cloud in AWS in 2006. So there's been a lot of connectors, ways that you can flow data into AWS now. In addition, a data lake and storage in general isn't good enough just to put the data there. Having really good management tools and governance tools around that tends to be pretty important. So we have a service called Amazon Macy, and that's a little M-looking thing on the top. And that is an AI-based service that reads, interprets data, and gives you some automatic classification so that you can have better security and control. We have data visualization tools, serverless compute, monitoring, auditing, all the sorts of features that you would be familiar with as within AWS. So I'm going to back out of this. I'm going to get out of the gritty detail a little bit and go back to this diagram around data architectures. Now, we saw the diagram before was starting to get a few sort of bits and pieces. So what I'm going to do is, just so it doesn't overload you, because I know you'll look at a lot of diagrams through today, I'm just going to simplify this view. So on the right side, these will where the roles will continue to appear. On the left side is where the new data sources will appear. The top part of the diagram, we're going to see data flowing into a data lake at the data pipeline. And on the bottom, we'll fill out the event pipelines. Now, what happens next? So this is the modernize, consolidate. And if you're launching projects, these are probably the first ones that you'll also be getting into. And it's a pretty common pattern. The second project, these are really exciting projects because these tend to be where you're doing something new with your business, or you're getting insights that allow you to go and shop for new customers or explore new markets. So this is the innovation layer. Now, innovation projects, they kind of tend to be owned by a couple of different people. Often people who are in the marketing group are very excited about knowing more about potential customer bases. But marketing people are kind of famously not really great data analysts. They're really good business users and they know what they want to do, but they may not have the programming chops. So there's kind of this relationship between people like Bala, who's head of marketing, and people like Christoph, who is the data scientist, will need to work together on projects. And unlike what we saw with Lim and with Raymond, where two different people just kind of go and pull what they need, there's this interesting work that happens between these two roles. So let's talk about what this looks like in building to that. Bala will ask questions like, how are people using it? We've released this product. Are people using it the way that we thought, the features that we put out? What are they listening to and when? And kind of what kinds of people love us and what kind of people are falling out of love with us? So increasing and decreasing usage. Now, Christoph, with his big crazy beard, he thinks of the world differently. He's answering the same questions, but he's answering questions through a different lens, which is around segmentations and propensities. He's looking for things like, are there signals in voice that we can look for sentiment? Trying to understand data through a lens of analytics and statistics. So Or can we infer user activity? If a picture's taken, can we do image classification and scene detection? Can we pick something up from that? Now these two, you can see that there's a relationship, but how they approach the problem will look different. So let's start with Bala. Bala's questions, again, coming down to how are people using it? What are they listening to and who? Who's kind of increasing and who's decreasing usage? He first goes to this new source of data, which is coming from the mobile app. Now, their mobile application that syncs to the smart buds is able to pull in things like the registration. So you first register, give your name and demographics, how old you are, and that sort of stuff. But the mobile app then contains the interesting bits, which is usage. Where and when, the time and the place that a person is using and consuming this service. Also, they've created partnerships. So when you click on your headphones, you're asking to play what? Podcasts and music, typically. So they've created partnerships with Amazon Music and TuneIn and Spotify or whoever else that might have a good partnership. But more importantly, that API interface allows them to see consumption. So it isn't just the data that they're collecting directly, they're also getting third-party data. Now, if you think back to what you're trying to work on today, this is a pretty interesting case. Mobile app data is non-transactional, it's non-traditional, and marrying together with third-party data that you might be getting from marketplaces or partners or wherever you source that from. Bala knows that he wants to ask the questions from these two, but he doesn't really know how to analyze the data himself. He knows that the signal's there, but he doesn't have the tools to do it. So he reaches out to Christoph with a problem statement. Christoph goes and he looks through that lens of, hey, what are segmentation propensities and so on. He first goes and he grabs that data and he says, I think that I need to load all the mobile data into the data lake so I can do something with it. Okay? And that kind of makes sense because those are direct signals, what we call dense data. So dense data will give you direct behavior that has been observed. Now he wants to go and say, I think that there's also some pretty interesting stuff that's sitting in heart rate. There's something that's sitting within GPS, within voice signals. I don't know what sits in there, but I believe, I have some hypothesis. This is a normal process for the data scientist to say, I'm pretty confident that if I test these three things, one of them is going to have some weight, and then the other two are just, they turn out that they're statistically not relevant. That data, importantly, does not load directly to the data lake. So data that is dense may go direct to the data lake. Data that is uncertain may not go directly to the data lake. Now, this may be different from what you have thought about or have approached it before because the approach tends to be using sandboxes. A sandbox is a very fast, cheap, low-risk way to start looking at data that is uncertain or you don't know if it's ever going to pan out. Let's just take the example of you're collecting something like GPS data and heart rate data, and maybe you're collecting this across 5 million users. That costs a lot to collect all of that data if it doesn't have any business relevance. So a sandbox is the way to take that data, test the ideas, and then if the data looks like it's good, then promote it to the sandbox. So let's go back to this architecture. It looks similar to what we saw before, but now there's a break. Data comes in, and these new data sources, things like these digital assets, clickstream, things from the web assets, connected device data, that lands, that's event data. It goes into the landing data or the raw data area, but now instead of loading to the data lake, it loads to a sandbox. Christoph goes to the sandbox and he starts running his hypothesis. So he starts testing against it, and he's using tools like PySpark, and he's using tools like SageMaker to build machine learning models. He may be a TensorFlow programmer, and he's building using deep learning frameworks. Really, whatever platform that Christoph is most comfortable, he reaches into that S3-backed sandbox. He tests his ideas, and he finds out that there's a couple of them that look pretty good, and then a couple don't. The data that's not interesting gets scrubbed from the sandbox. It doesn't become an artifact. They're not paying for data that no longer adds value to the business. Christoph publishes two things from that analytics layer into the data lake. So this is what goes to the data lake. The dense data that has proven value, and second is the output data sets. So maybe they've created some propensity data about the users. The result data sets will get published as well as the raw data related to those experiments. Now, if you think about that from a narrowing standpoint, that gives EarEcstasy the opportunity to really optimize what they're paying for. Essentially, they only end up paying for the stuff that directly contributes to the business. So again, this use of sandboxes being pretty interesting. At this point, Bala says, okay, now the data's living in the data lake and it's user data with propensities and I have segmentations. Now Bala knows what to do with it. He uses the tools that make sense for him, which may be things like marketing automation tools to do an import of that data, and then he can run some campaigns for those people. So the relationship between the data scientist and the marketer is often facilitated by using this sort of experimentation and publish framework. I'm going to simplify this diagram again because I'm not trying to be mean and put a whole bunch of crazy stuff on the slides. I'm just going to simplify this down, but you know, underneath this, there's a little bit more complexity around sandboxes and all that stuff. Data will flow in, and now we see that that left side around sources is a lot more complete. We've seen transactional data and ERP data, how that flows in. We've looked at things like digital assets through clickstream and weblogs, and we see connected devices and even social data. So we've seen all the patterns of how that flows in. We've also now seen, in addition to business users and data analysts, we also now see where data scientists fit into the access of this platform. Here's the third and the final outcome. And this tends to be sort of I won't say the end state because it's an ongoing set of iterations. But real-time engagement is something that a lot of organizations are really hungry for. And I give you the example of EarEcstasy, but all of our really big marquee customers, they care a lot about understanding what's happening and responding to customers in real time. It could be with giving somebody the best car booking. It could be with giving somebody the best movie recommendation. It could be when you walk up into a loyalty lounge at an airport, the person at the counter recognizes you in real time and treats you like the VIP that you are. So real-time engagement projects are really meaningful to the business. EarEcstasy's idea was, can we take these smart buds and create a personalized life soundtrack? Wherever you are, you're doing yoga, you're reading a book, you're going for a run, whatever you're doing, EarEcstasy has the device, understands enough about who you are and how you like to listen to music and people who are like you, that maybe they can offer you the perfect music at that moment for the kind of experience that you want to have. So you have the smart bud and you hit the button and say, I'm kind of tired. Like, play me some music. So EarEcstasy says, okay, I'm going to capture that data off the device. It goes back to my mobile phone. It goes back to the cloud and, all right, I need to do some NLP. I need to understand what the context is. The request, I believe, is the action is play, the category is music, but I need a recommendation. I don't know. So I need to find that information from somewhere else. So Kinesis Streams has captured things like location. It's captured things like the mood. So maybe trying to make those basis determinations off of GPS and heart rate as an example. Okay, now I have connected device data. Now I have the requested content. If I pull those together, I match that with the history of that person, what they've listened to before, I'm in pretty good shape. I probably have like a 70–80% chance of giving them the right recommendation. But if I match it together with something like clustering, so I've made a random forest model to say, based on these factors, these are the people who tend to cluster together in this environment, I can now give them a recommendation, say, oh, you're tired, for you at this time, we're going to give you 21 pilots. I'm biased because I saw them and they're awesome. But so let's say 21 pilots for this kind of user. Fairly complicated to do that in any other way, but to have these streaming services pull data from two different views, run it through models that were already built, can give a very personalized recommendation. That's just off, say, have a voice request. But they wanted to do something edgy. And I put this in, and I want you to suspend disbelief for just a moment with me. Because although the use case here might seem far-fetched, which is, I'm somewhere and I just want to take a picture of where I am. And based off of where I am, please give me the perfect music. Okay, does that really work in real life? I don't know. So this is just an idea. But I want to illustrate this because the complexity of, if you imagine today, you go and try to solve that problem, it's really hard to do, right? Take a picture and pick music based off that. So how did they solve this? They first took the image and said, can we do a basic classification to understand where the person is? So using a service like recognition image, Maybe pull some things like, oh, I see a chair, I see a desk, I see a lamp. I think that you're in an office. But that could mean a number of things. So I want to have I just want to have something that's a little bit more detailed. So I want to do a really deep scene identification to say what kind of office. So using SageMaker and using the image classification models that have been provided, they've trained this to say types of offices. So to see, are you in a shared workspace? Are you in a cube? Are you in a call center? I don't know, like, what is your office? What kind of office is it? By using scene detection, so using image classification and using models that can do, well, if you go, there's another session we'll talk later around SageMaker usage, and we'll talk about transfer learning. You can quickly train models very specifically on types of environments. So matching these two bits of data together, say, you're actually in a quiet office. Well, based on being in a quiet office, based on your history and people who are like you, you're working. If you're working, this is the kind of music that should be relevant for you or that you would love the most. So it could be you're a Mozart person or you're whatever it is that you listen to when you work. If you're developers, it's probably going to be more on the EDM side, but let's just say that it's Mozart. So picking the right music on environment, but again, pulling data that's very non-traditional, using something like an image and converting that through to behavioral preferences. If we pull this back in, and this is kind of the last and final view of what the architecture looks like, and again, a little bit simplified, but essentially, if you really peel the covers back and look at some of our most advanced customers, this is how they solve problems. They start with the people who are on the right side. They dig back to the smallest amount of infrastructure, the smallest amount of data to answer the questions. They start small and iterate. They experiment, and only experiments that look good, they scale. Now, we have the data pipelines that are on the top, but that machine learning and analytics layer, it publishes models. So we talked before about publishing data sets. Those data sets have, these customers have these preferences, please move that up into say, marketing automation. But it also produces predictive models. And predictive models, depending on what you're using, they could be, if you're in a sort of traditional behavioral analytics, it might be PMML files that publish. They could be ONNX if you're doing deep learning. There's different types of exchange formats. But that model publishes down into the event layer. The next time the person speaks or they take a picture or they're even out running somewhere and it says, give a recommendation, that is the event trigger. The event trigger then goes to the prediction layer. It takes those pre-built models. It may use AI services like comprehend and recognition and all those models that help give context. It then scores the event that's happening. Based on that, a recommendation is given, and then an action, which is play music, is then taken. So the relationship between collecting data, building those profiles, servicing those 5 different kinds of roles, and then publishing those to be able to respond in real time, this is a pretty common pattern. So if we kind of wind this back, what have we seen? Business outcomes tend to kind of come in 3 waves. The first wave, most customers will embark, and something maybe to consider is starting with first a simple modernization and consolidation project. The second will be around innovating for new revenues, looking for ways to find new customers and really find new ways to engage with the customers who you have. And the third is finding a way maybe to do that in real time. So looking for opportunities to say, are there ways that we can better service the people who make our businesses successful? So where to get started? Are you ready to build better business, from the ideas that you have? And I think most people have some appetite for it. So we'll kind of start, there's just 3 different things that I would recommend. One is, rather than starting with a big bang, and I think all of us have been in the industry for long enough to know that you can kind of get there, but it's expensive, it's time consuming, and if it fails, nobody's really happy. So starting with a short list of projects, of things that would make the most difference to your business. And I think just out of experience, if you're starting with things that involve directly things that impact customer engagement and customer adoption, you're probably starting in a place that you can test your experiments and you can see the results. So not necessarily starting with optimization and cost takeout, but probably starting projects around customer engagement. The second is introducing data pipelines and introducing experimentation frameworks. even if it's unfamiliar, the benefits of being able to decouple, start quickly, test, and then scale kind of outweigh that initial learning curve that may happen from doing something that is new. And again, this pattern, we see it across a lot of our customers who are very successful. The third is, you may have started this and you're finding like, oh, we've got these great ideas, but we need a little bit of help. So we have very specific roles that we've hired to try to help you. One are solution architects, or what we call SAs, and they're at our booths today, and you'll have a chance to chat with them here. But our SAs will help you take an idea and map out a good starting point, give you some reference architectures, give you a way to really get moving. And if you are looking at something like production builds, we do have professional services that are put in place directly for that. So would encourage you to, the best that you can, get started, get your hands into it. But if you need help, please do reach out to us. Want to thank you very much. We do have, of course, one of the things that's really important for us is making sure that we've given you the right kind of information and made it worth your time. So please do fill out the session survey. And I want to thank you very much. I hope you guys have a great day.